Assalamualaikum and good morning. Hi, my name is RIDWAN bin HIRZUN. My SB is Professor IR Dr. HAMBALI bin AREP, alias ARIF. Today, I will present my PSM topic, which is Environmental Impact Performance using Life Cycle Assessment at the Conceptual Design Stage, a case study, Machinery Machine. Okay, on to the next slide. First, this is the introduction. I will talk about the seaweed. Seaweed is an aquatic plant-like alga that is found under the sea. Nowadays, many seaweed used in everyday life such as food, industrial application and fertilizer. Next is the fluidizer bed granulator. The fluid bed granulation has been widely used for many decades to enhance powder property such as flowability and compressibility for downstream manufacturing. The next one is the life cycle assessment. Life cycle assessment is a method for determining the impact of cradle to grave on the ecosystem associated with all stages of life. The cradle to grave means that when a product is made, it is evaluated until the end of its life cycle. After that is the spin grind dryer. My main objective is the spin grind dryer, which will implemented the life cycle assessment on the spin grind dryer. The spin grind dryer is a project collaboration with Sanen Utama. Spin grind dryer is used to spin, grind and dry the seaweed product for Sanen. Okay, on to the next slide is the problem statement. For the seaweed, it has a long processing time, especially drying. There are many drying methods such as drum dryer, fluidizer bed granulator, and many more. Mostly the conventional drying use the sun as its source of heat. The use of conventional drying takes a long time for it to dry. The next one is the fluidizer bed granulator. The fluidizer bed granulator only capable of mixing and drying. It lacks the grinding mechanism. The proposed product of the spin grind dryer requires that the machine can spin, grind and dry. The main problem is the grind, where all the machine in the market only have one or two criteria, whether it's drying or grinding or drying and spinning. The next one is the environmental impact. The proposed product may harm the environment due to its material. There are many cases where the product use the LCA but does not fully utilize the LCA. The next one is the objective. My objective is to study the environmental issue in designing the spin grind dryer. The second objective is to evaluate the environmental performance in accordance with the lifespan of current machinery machine. And the third one is to propose a new ecological assessment framework using the LCA approach. My scope is mainly focused on fluidizer bed granulator and life cycle assessment to be applied to the spin grind dryer. The next one is the literature review. For the design method, there are conceptual design, life cycle assessment, and CIMA-PRO. For the conceptual design is the first step of the multi-phase process involved in creating a new product by Stephanie Faris, 2018. The next one is the LCA, where a technique for assessing the environmental aspect associated with a product over its life cycle. LCA provides the quantitative and scientific basis for all these activities by Shelley, 2019. And then the CIMA-PRO. CIMA-PRO is based on the robust science of LCA, the leading method to measure product sustainability by Mark and Company, 2016. The next one is the methodology. For the first methodology, I use a total design approach. There are three types, which is the conceptual design, concept generation, and concept selection. My main focus is the conceptual design. I must evaluate the product, the proposed product, before it is manufactured or is made. The conceptual design is very important to ensure that the product has a long lifespan. The next methodology is a software implementation. I will use the CATIA software for the design stage, and then I will be followed by the CIMA Pro software to apply the LCA. The CIMA Pro software already has the LCA implementation embedded in the software. And so I will use the CIMA Pro to evaluate my conceptual design. The CIMA Pro application software flow is create a model outline in Canvas. Alternatively, import for an existing project from CIMA Pro, and then add library process, use parameters, and then edit calculation setup and calculate result. The CIMA Pro is very important to ensure that I can achieve my objective for the environmental impact of the spin grind dryer. The spin grind dryer is a collaboration with Sanen, and I have a partner who focus on the spin grind dryer based on using the MFA. My main focus is the life cycle assessment to ensure that this proposed product is environmentally friendly. The next slide is the expected result. My expected result is to show the difference between the old design and the proposed design in terms of environmental impact performance using the proposed framework. And the next expected result is to show the importance of implementing the LCA in evaluating environmental product performance during the early stage of product development. These two expected results is very important to me because there are many cases where a certain product may harm the environment because of its long lifespan. For example, if there is a product engine car which is thrown into the environment, but the material has a long lifespan, so the corrosion will impact heavily on the environment. That is all for my slide. Thank you very much.